Hi everyone, in this video let us show how to create an Amazon EKS cluster and also deploy EMR and EKS virtual clusters on the EKS. Okay, so let's get started. So here we will be first deploying the VPC and the subnets. So let us configure the terraform.var files. So here I said create VPC true and number of AZs to consider is 2. So I'm not using 3 AZs, but I'm using only 2 to ensure that we have lesser data transfer cost and also the improvement with respect to the latency between the driver and the executor parts when you run the Spark applications. Okay, and the VPC name is EMR and EKS. The CIDR block what I choose is 10.0.0/21. Okay, so this is smaller CIDR comparatively. Yeah, /21 is basically 2000 IPs, right? Most of the times companies do not have enough RFC 1918 space to allocate for the IP, so they will have a smaller CIDR sizes. And most of the IPs for the pods and the nodes should come from additional CIDR blocks that we will configure. So we are using only 2000 IPs, and we will see how to effectively leverage these IPs. So the subnet what I'm creating is first of all the data plane subnet, which is /23. Okay, so this is around 512 IPs times 3, which will be around 1500 IPs. This subnet will be used for data plane. When I say data plane, not the nodes, but private NAT gateways, internal load balancers, and things like that. Then I'm creating a public subnet of size /25. So /25 is 128 IPs times 2. Um, Sorry, the previous case it is 512 times 2 because we have only two subnets, right? So it's 1000 IPs. Now in this case, /25 means 128 IPs times 2, which is around 256 IPs for the public subnets. Similarly, for the database, /27, which will be around 32 times 264 IPs. Now for the control plane, it will be /28, which is 16 times 232 IPs. So we can choose different sizes based upon the requirement. I just took one sample configuration. Now we'll do Terraform init plan and apply, and let's go proceed further because I've configured some more things in this module. Okay, so let us first um, look at the VPC and subnet sizes that is getting created. I've already run the Terraform init plan and apply, so let me just run it again, just ensuring that if any other changes are there, they'll be applied. So Terraform plan um, plan is also completed. Now I'll be running the Terraform apply, auto apply, apply with auto approve. Okay, the VPC and the subnets are created. Let's go to the VPC console. So this is our VPC, and if you see the subnet, let us look at the names here. So the EMR and EK is private. CP stands for control plane. So 1A and 1B, there are two subnets, each of them of size /28, which is 16 times 2, 32 IPs. Okay, this is used only for the control plane and data plane connectivity to place cross account ENIs. The second one is database. DB stands for database. For database, I'm using /27, which is 32 times 264 IPs. Okay, this is to place any ENIs for managed databases or to run any self-managed database on the EC2. And public subnets of size /25, which is basically 128 times 256 IPs for any public load balancers like NLB or ALB, any ingress endpoints there. Okay, so the next one is basically the private DP. Private DP is basically /23, which is basically 512 times 2, which is 1000 IPs. So bulk of the IPs from RFC 1918 goes here because this is where we will be deploying internal load balancer for the various applications. Okay, and the secondary header blocks is where the DP secondary. This is where the 16,000 IPs comes. Sorry, 65,000 IPs per subnet, which is 1,35,000. Right? This is huge for any scale. So this is how we can leverage the secondary headers for the nodes and the parts. Now we are not using the custom networking here. In the case of custom networking, the nodes will take the IPs from the 10 series and the pods will take the IPs from the 100 series. But here the both pods and the nodes are taking the IPs from the 100 series only. So this is like additional shader blocks, not really a custom networking. It depends from customer to customer. If they have enough IPs in the 10 series and the nodes needs to talk to other clusters in different um, same region or different accounts for various use cases. But here we are just running the Spark applications. Most of the times we'll expose these applications through a load balancers which sits on the 10 series anyway, which is a routable IP. 164 can be hidden like a overlay IP. Okay, so this is a VPC configuration. Going further, let us proceed further, and we are configuring the EKS cluster. So we are creating create EKS is equal to true, name of the cluster so and so, and version. And again, I'm applying this. I've already done that in the interest of time. So the cluster is created. So the cluster which is just created is this EMR and EKS, and it is using this VPC that we saw just now. Okay. So the cluster is also created. Now, apart from that, we are basically creating the EMR and EKS virtual clusters. Before we go to this, let us first understand where exactly this cluster is created in the first place. So if you go to the main.tf file, and this is my module which I'm referencing, right? So this is my blueprint. This is where I created a very flexible blueprint. You can either use an existing a VPC or EKS cluster or create a new VPC or cluster, and you can enable a lot of features like what is the subnets you wanted to enable, build in this VPC, things like that, right? And you can provide a lot of add-on configuration also. So for now, I've just created VPC and the EKS cluster with this module. And the third one is basically creating EMR and EKS virtual clusters, okay, and FIS experiment template. This we will see later. First, we will look into the EMR and on EKS virtual cluster. So there are two data teams, Team C and Team D, and they want to run their Spark jobs with the different versions of the same EKS cluster. So we have to create a namespace and do a lot of role binding. So the code that I'm using to do this is a very simple code. So let us go through that. This is the Terraform module, and I'm iterating through the list of teams, and this is the cluster ID, cluster name, and this is OIDC provider. This is the name of the virtual cluster, okay, and we are also creating the namespace. So we don't have to really create the namespace ourselves. This module will do it for us, and we also have to create the execution role, okay. The execution role is basically IRSA role. When the when the driver and the executor pods gets created in this namespace, they will assume this IAM role to access the AWS resources. That could be S3 for input and output data, or CloudWatch for logging purpose and things like that, right? So that role should have the required permissions. And so this is the role name and description and any other policies. So for example, I wanted to access S3, so I'm giving the full access, and CloudWatch logs I want to enable. So this is simple configuration for the module and through which I'm creating two virtual clusters. Okay, so let us go through and run it. I've already run it. Now, if you look at the output, so let's go to the output and see what has been created so far. Um, so the team C name is this, and the job execution role, ARN is sensitive. Okay, but the name is this. Okay. Now this is a virtual cluster ID for team C, and this is a virtual cluster ID for team D. So there are two teams, where each of them there is two virtual clusters created. Okay. Now let's go to the EMR console. So this is my EMR console. You will see the virtual clusters here. Under that there are two teams, team C and team D, and which are created. Now this is the cluster name, and this is the namespace. Okay. Now let us submit some jobs, okay, on these clusters. And before we submit any jobs, let's first, get access to the cluster first, okay. So I am basically creating a kube context file to access my cluster for this name, and I'm using my EKS workshop admin role. So this is the IAM role which I'm using to create the cluster, and the PC on which I'm running all these commands is actually configured with the IAM user. but the cluster is created with this role. So that user has to assume this role. So that's the reason I'm using this. I've already run this command. Now, if you see kubectl get nodes, you will see the list of nodes in the cluster. Okay, that means I'm able to access it. Now let us see what RBAC roles are created automatically by the Terraform module. Okay, so if I see the get role in this namespace, so this is the RBAC role which is created for the team names for the team C in the namespace. So if I look at the RBAC permissions, like what this role can do in the cluster, right? So you will see the list of operations and various API objects, right? This role can do. Now, who is going to assume this role? Now, let us look at the role binding also. Um, so this is the role binding that is also created in the same namespace. And if I look at the description, I mean detailed view of this role binding, we will see that there is a user called EMR-containers. So what does it mean? Kubernetes, we are creating a Kubernetes user. Instead of I would say creating, we are mapping to a Kubernetes user called EMR hyphen containers, and this Kubernetes RBAC user is mapped to this role. Okay. So if you have multiple teams and all of the teams namespaces will have the corresponding RBAC role like this, and all of them will be mapped to the same user. Okay. So this is important to understand. So who will assume this RBAC role? The EMR service, when it submit the jobs on the cluster, that EMR service role will be mapped to this. Okay, so we will see that in a minute. So here I'm just outputting the AWS auth config map into a file, and I've already run that command. So let me open that file. So here, if you see, this is the EMR and EKS service. It's AWS service link role. Okay, so EMR and EKS service is using this role to talk to the EKS cluster. And why does it require to talk to the EKS cluster? Because we are submitting the jobs. So when the users are submitting, we are not directly submitting the EKS cluster. We are making a calls to the EMR service, which internally will talk to the EKS cluster. So the EMR and EKS service will use this role to talk to the Kubernetes cluster. But this role has to be mapped to RBAC. Otherwise, it will not have any authentication authorization, right? So this is where we are mapping this role to the user called EMR-containers. Now this is the user which is mapped to the various roles that we saw in the different teams, team C and D. So any team that wants to perform some operations in the cluster, their namespace, they should have the corresponding RBAC role, and that role has to be bound to this particular user. So which we saw that all of that is automated already using the Terraform module. We saw that earlier for Team C. So this is important to understand. So right now we are using the AWS auth config map, but eventually when we support, for example, API mode, AWS auth config map is no longer required. So for example, the Kubernetes EKS supports three API mode, authentication modes. One is the config map, one is the config map and API, and there is the API mode. So we are using currently config map and API, the middle one. So that means for any authorizations, you can use the AWS auth config map, or you can use the RBAC also, or you can use the authorization authentication policies. So we will discuss that in a detailed section, but for now, since this is not yet supported at the time of recording this, so I'm using the AWS auth config map. Okay, so this is how everything is linked together.